Hello everyone, and welcome to Understanding Physics, in which I will guide you through thinking as a physicist. So, today on General Physics 1, I want to discuss a little bit about using Newton's law. So, so last time we have talked about the three laws. The first law states that if the force is zero, the velocity is constant. 2. If the force has a value, the net force, it will, so the net force will be equal to the MA. And then lastly, every action has a reaction. So those are the three laws that we're going to be used into understanding physics. So here are some tips in which how you will actually try to solve problems in physics. So for this video, I want to discuss one of the most simplest problems in physics, which is if you have a block in a slope. But to do so, we will start by setting out how will you actually solve the problem. So first, what you want to do is to actually determine. So the steps first is to determine the forces. Determine the forces. Second, you want to create a free body diagram. Third, draw vectors using components. And then fourth, you will use Newton's law. And so this will work for only a single object system. But if you want to do multiple different objects, you will need to create much more free body diagrams. So this will be free body diagrams for each object. And so this is one of the key components that you will need to know. And so another thing is that I will also describe one of the most essential law in like figuring out what is the movement, which is the circular motion. Circular motion, as we last time proved, the acceleration is v squared over r, which comes from mathematics. And so in a circular motion, you would figure out that the net force will be ma, which will equal to the mv squared over r. And so this is one of the important things you need to always remember, just in case if you are dealing with something that is rotating. You could figure out what is the force, and thus you would know what's its velocity as well as its radius of curvature. And so another thing that I want to talk about last time was friction. We didn't discuss a lot about friction, and so now I want to introduce the concept of friction. So there are two kinds of friction. One of them is static, the other one is kinetic. Static friction is the one that prevents something to move, prevents movement. And so this basically means that the force in one direction must be equal to the force in the other direction, where the velocity should be zero at the first place. And so the way that we'll write this is that this will be Fs, and this is the friction force. But there is a maximum of this value, which is mu s multiply that by the n, where n is the normal vector. So this basically means that basically the maximum friction force comes from a constant, multiply that by the normal force, and 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 that is what's the static friction. The other type of friction, the kinetic friction, is always the same value. So basically, it is the kinetic friction will be equal to mu k, multiply that by m. So there are like some slight difference between static friction and kinetic friction. One of them is its coefficient. The other one is that kinetic friction is always constant no matter what your speed is. And so that is one of the most important things for you to actually remember about. So there is also one thing that I will also try to discuss, which is the drag force. Drag force is drag force is something that is related to its velocity, and this will basically relate towards its terminal velocity. And so if you have any problems within drag force, you should already have the formula to convert its velocity to a resisting force. So now we want to discuss the problem that we're going to try to discuss, which is the block on a slope. So in here I have a block, and and let's just state that, yeah, it has a mass, there is gravitational acceleration, and there's an angle theta, as well as there is a coefficient of kinetic friction to be mu. The mu k will be mu. So how do we solve this problem? So first, let's just state that the block will be moving in this direction. Let's state that it is not in a static condition. So there are multiple different forces. First one, what we saw is that there has to be a weight on the object. The second, there should be normal, in which that the block won't face through inside this ramp. Third, we could also see that there should be friction. And so those are the entire force that we see on this object. Sometimes you might see there is tension, there could also be a driven force. But in this example, we only see that there's weight, normal, as well as the friction. Or yeah, basically the kinetic friction. Kinetic friction. So we have talked about all of the different forces. And so now we want to discuss its free body diagram. The way that you draw a free body diagram is to denote it as a point-like mass. And you can see that it has weight going downwards. There's a normal force, as well as there is a kinetic friction. So we want to write this in terms of components. And the easiest way for us to actually write this into components is to actually describe it in this direction. Why is that? Because we know that the movement in the y direction, in here, this will be the y, this will be the x. The movement in the y should always be a constant, and so that means that its force should total to be 0. So if we actually draw these guidelines, we could see that there is there is an angle in this direction, right? And then there is this other guy going in that direction. So we want to figure out how do we know what is this angle in response to the other axis, which is this one, is the weight. And so one way to do this is that we saw this to be this is like a geometry problem. So let me just try to draw this better. there, there, and then there's weight going downwards, and then this one is in a right angle. So you can see there is a right angle here, there is also a right angle there. But here's the most important part. If that is theta, we know that this guy should be 90 minus theta. Therefore, this angle should also be theta. So we know that the angle from here to here will be theta. So, after we have already figured this out, we could write this guy into its components, which I will draw in blue. So there will be a vector in this direction and a vector going in this direction. So the one that is going in this downwards direction would be the weight multiplied up by the cosine of theta, because it is the hypotenuse that is already known, and then we want to figure out what is the length of this part, which will be the adjacent side, while this one will be the sine of theta. So okay, we have like gotten this information. So now we will try to use Newton's law. So first, so we can discuss it into these two different axes. First, I want to try to discuss in terms of the y-axis. So we figure out that the normal force subtracted by the weight of cosine theta must equal to 0, because it is not changing speed in this y direction going this direction. So we will figure this out, and then we know weight to be m times g, so therefore we would know that the magnitude of the normal force will be mg cosine theta. Okay, that's good. So now we have another problem. Is that let's just state that w sine theta subtracted by the friction of the kinetic must equal to ma. And we don't know what the a is, but we know what the mu is, as well as we know what the weight is. So we could just actually write this down into mg sine theta subtracted by mu k mg cosine theta, and this will equal to ma. Oh, you can see that the m's will later cancel each other out. That's good. Therefore, we know that the acceleration is g sine theta minus mu k g cosine theta. And so you can see that basically if the theta is 0, this will mean that there will be much more force from the kinetic friction compared to the gravitational acceleration. And this doesn't make sense. Is that the friction will go into a certain direction. And so this is one of the things in which this equation will fail. But as long as this equation is greater than 0, this equation will later make sense. And so there's like special cases for you to actually remember. So we have already discussed all of this, and then we have figured out what's the acceleration. So therefore we could figure out what is the movement of this object. So we could actually just go straight away towards the simulation in which I have already created. So here is my simulation. You can see here that I have an object, and yeah, it is sliding down. So let's just actually increase our let's just increase our angle here. There we go. And then let's just increase some of the friction to be 0.5. Let's see. Let's set time to be there. Okay, you can see here that I have already drawn all of the forces. You can see there's weight going down. You can see there's the normal force trying to counteract this guy from going downwards, and then there's this kinetic friction going backwards. And when this friction goes becomes no sorry, uh, if you try to sum all of these factors, you would find the net force will go in this direction. That means that it will later accelerate towards this direction, not a value perpendicular to it. And so from the simulation, we will later figure out that this guy is going down, speeding up. It is like going down, speeding up. So okay, this makes sense. And so now we have a thought question, which is, what if I set the mass to be lower? Does that mean that it will later slip slower? The answer is not, because we have already derived from the equation that in the end the mass doesn't matter. And so if I decrease the mass, you could see that you could see all of its forces decreases, but its acceleration is the same. And so you could also do this within different gravitational acceleration. Let's say it is within like Mars, for example. You can see that it is like traveling much more slower compared to before. Another thing is that we could actually increase the static friction. You could see that it is like trying to move. Oh, yeah, you can see here that the simulation starts to break, because you can see that its force starts to go in the opposite direction, which is so wrong. So there will be a value in which there will be a balance in which that this value must exist. And so you could also control the angle. Let's just actually increase the let's just decrease the friction so that this will make sense. Oh, I'll put that to be 0.09. You could see that it is traveling much more slower compared if you put it at a higher angle. Compare that to something like that. And then also this will later break during a certain angle. You could see from here, which is basically that its friction should be greater. That means that this object should stop. But don't forget that I didn't include static friction in this simulation. So there will be some breakdowns in this simulation. So therefore, if you are trying to do physics, you must also remember what is the range in which these equations exist. Because the real world is not easily interpreted into mathematics. There are only special conditions. So, that's all for this video. I hope that this will help your understanding, as well as try to solve some of kinematics problem, as well as like dynamics problem. So thank you very much, and I will see you on the next video.